Um, this is kind of the last part of 4.9, and then they throw this like checking account question at you, where when you write a check, the money comes out of your account. When you make a deposit, it adds. So they just want you to be able to add and subtract all the numbers in order. When you write a check, it gets subtracted from the account. When you make a deposit into your checking account, it gets added. So the key thing being the beginning balance, 482. I got like this whole thing going. Over the course of the month, Mallory checks and makes 2 deposits. I got $468.79. You just kind of put it all together. Okay, adding and subtracting. Then we are introduced to different properties of real numbers. Maybe this will help you with some of the fun facts that we talked about before, like negative times a negative or things like that. Commutative means order does not matter. This is kind of a thing that works with addition. And multiplication. If I made a subtraction problem, let's say I did 2 minus 5 equals 5 minus 2, we know now that that wouldn't work. That's kind of what they're talking about. The order in the subtraction does matter, because you would get 2 minus 5 is negative 3, and then 5 minus 2 is positive 3. This is no good. Multiplication property of 0. Any number multiplied by 0 is 0. Example, 2 times 0. Gotta make it exciting. All right, here's one that we kind of talked about before when we said reciprocals, but we've never called it an inverse before. Multiplicative inverse. If you flip the number and multiply it, you will get 1 every time. 3/4 to the reciprocal of 4/3, and you'll get 1. Kind of another way of saying that is 3/4 times 4/3. Well, 3 times 4 is 12, right? And when you multiply fractions, you multiply straight. It becomes 12 over 12, and any number over itself is 1. I kind of do recall a question about the associative property. Here's what it'll look like. 2 plus 3 minus 1, and then 2 plus 3 minus 1. Actually, this will be different. So make this like that. So again, kind of something that works with addition. If I change the location of the parentheses here, it doesn't change the answer. 2 plus 3 is 5, plus 1 is 6. 3 plus 1 is 4, plus 2 is 6. So you get the same answer in that particular setup. Why are they giving you these fun terms that you'll remember forever? It's so that you can reduce fractions. And they're going to give you a really long problem like 3/4 times 2/3 times 5/9 times 4/5 times 9/13 times 26 over 4. We won't have to work and make a common denominator or anything like that, because we know that if I have the same number on top and the same number on bottom, they will cancel out. I don't know. You might be right. I don't know. I didn't think about it. Yeah. So, yeah, I don't know however way you want to look at it. Maybe if I made one big thing like this, you could see it. You could also kind of do it like this. Let's see. So you see how the 4s will cancel? And then what else do I see on top and bottom? How about the 5s? 3s. 9s. Orange. Um, 26 and 13. Now that doesn't cancel, but it goes into 1 and 2. Right. You can also reduce on the top and bottom, sure. And then 2 and 4 will reduce to 1/2. And if you haven't seen it already, then you have 2 over 2. So the whole thing does indeed become 1. They're just trying to get you, they're going to give you a whole bunch of big numbers, and they just want you to, like, don't multiply them all together and get like a number in the thousands. They don't want you to do that. They want you to just spend half a minute on it. You know?
Suppose you did multiply them all across and get one fusion, but could they eventually cancel each other out?
Yeah. Yeah. That's true, and plus you would get this. You'd probably get the same number on top and bottom. So you would say, okay, it's just 1. It would be like 1,028 over 1,028. I don't know, but yeah. Combine like terms. When we simplify, try to say this. 3x to the 4. We talked about this last time too, right? The coefficient is the number that's in front of it, in front of the variable. The base is like the variable. It could be x, y, z, and then you have the exponent. The real official way of saying it is they have to have the same base and the same exponent to put them together. I will explain this in a semi-unofficial way. The things that go together here I see are the 9x squared and the negative 2x squared. So I have two apples. 9 minus 2. Leave the exponent alone when you add and subtract. So this would become 7x squared. Oranges. 3x and 3x. So 3x minus 3x, well, think of it as just 3 minus 3. So that cancels out. We could write 0x, but the computer is not going to want that because 0 times anything is 0. And then a blueberry. So 7x squared plus 13 is what they want.
So you just eliminate that x altogether.
Eliminate the 0x, yes, because of the rule. Anything times 0 is 0. Yeah, positive 3 minus 3. Yeah. Yeah, so you still got to carry those variables and exponents with it.
When's our midterm? It's like the 5 students up for okay.
Oh, man. Okay, I'm just going to do a couple of these. I'm trying to think if they throw the distributive property at you in the problems. It'll be good to do anyway. So I want to start with C. The distributive property occurs when you have a quantity there and you're multiplying the thing in front of it, in this case the negative 1/3, to both of them. So I'm really going to write this out every single step. This will be negative 1/3 times 9x plus negative 1/3 times 2y minus 3x. But you can do it. It's not that bad. 1/3, negative 1/3 times 9 is negative 3. Because remember the rules. Think of 9 as being 9 over 1, and now you're multiplying two fractions. So it becomes negative 9/3, and that's negative 3. right? So all the rules start coming back. So now this is going to be negative 3x plus, again, think of this as 2 over 1y. So now I have negative 1 times 2 is negative 2. 3 times 1 is 3.
Wait, so that negative sign doesn't.
Yeah, I think I know where you're going. Like, why did I write plus minus there, right? Maybe?
I'm confusing myself.
Okay. So now I have negative 3x minus 2/3 y minus 3x. And then I see like terms. 2 grapes. Right, so now those go together. So now I have negative 3x minus 3x. Those go together because they have x's. It doesn't go with this because it has a y. Remember, they have to have the same letter. So now what's negative 3 minus 3? Negative 6. X minus 2/3 y. Believe it or not, that's as simple as it gets.
She's gonna die right now.
I'm going to do one more problem. Any questions on this? Yeah, because the whole thing about like terms, x doesn't go with y. Can't put them together.
I remember from back in the day.
You can distribute a minus. So look at the thing on the right. Negative parentheses 12x minus 4. We kind of mentioned that you can imagine that there's like a 1 in front of that. Suppose that I put a little 1 there. That will get distributed to everything in parentheses. So say to yourself, negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6. Negative 1 times 12. Negative 12 with the x. And then negative 1 times negative 4. Positive 4. Combine like terms. Negative 2 minus another 12. Negative 14. X. And then, let's see here. Negative 6 plus 4. Negative 2.